So welcome back. We are into the second lecture of indefinite integration, standard forms and theorems, along with the proofs that we are doing. All right. Now, in yesterday's class, we studied few standard forms and their proofs. Okay. Now, today's class, we are going to, first of all, if you are aware, in your exam, at least in the last questions. Okay. Now, today's class, in the last question, you will be coming across a theorem, either a theorem or a proof, or both in integration. So, the part that I'm doing right now, this series that I'm doing for indefinite integration, this is going to give you at least 4 marks. So 4 to 7 marks in the final exam. So we are going to do an important theorem. We are going to begin with an important theorem from indefinite integration. That is method of substitution का theorem हम लोग अभी start करने वाले हैं. So let me share my screen first. All right, this is something we did yesterday. Okay, let's begin with today's class, that is integration by substitution theorem. If x is equal to phi of t is a differentiable function of t, then integration of f of x dx is equal to integration of f of phi of t into phi dash t dt, right? Now, as the theorem says, the theorem itself says that x is a differentiable function of t. Okay, who says? The theorem says, right? It is that is given in the question, given in the theorem. All right, now that means the meaning of that is x is equal to phi of t. X is equal to phi of t. अगर मैं इसका derivative लेता हूँ, if I take the derivative of x with respect to t this time, that will be equal to phi dash t, right? Let me mark this as equation number 1. Let me mark this as equation number 2. Okay, now once this is done, let integration of f of x is equal to, generally, if you remember in yesterday's class, I described that whenever we take the integration of f of x, we write it as g of x plus c. As of now, I'm just writing g of x, right? So according to the definition, it is integration is the antiderivative. That means the derivative of g of x is equal to f of x as per the theorem. Let me mark this as equation number 3. Now this is as per the definition, not theorem. Okay, now let's come to the next part, that is the important part of the theorem. Now, by chain rule, that means composite function के बारे में जब हम बात करते हैं उसको कहते हैं chain rule, that we studied in derivative. By chain rule, if I'm finding out the derivative of g of x, but with respect to t this time, I'm not talking, now this is very important. Here it was with respect to x, here I'm taking with respect to t, right? Then that is equal to, first of all, because I can see it is the function, g is the function of x. So I'll first take the derivative with respect to x, and as a part of composite function or as part of chain rule, I will take the derivative with respect to t, derivative of x with respect to t. Now, as per the equation number 1 and 2 and 3, देखते हैं step by step. Derivative with respect to t of g of x. Now, this part, d by dx of gx, according to equation number 3, it is f of x. What is dx by dt? According to equation number 2, it is phi dash of t. From where did I get this? From equation 2 and 3. Okay, now again, once again, d of dt of g of x is equal to f of x. What is f of x? According to equation number 3, once again, what is f of x? Equation number 3 says that, sorry, what is x? Equation number 1 says that x is phi of t into phi dash of t. This is according to equation number 1. Now, by definition of integration, बेसिक डेफिनेशन इंटीग्रेशन का क्या बताता है? It says that if the derivative of g of x is this, that means इसका इंटीग्रेशन क्या हो जाएगा? g of x हो जाएगा. That means g of x is basically the integration of f of phi of t into phi dash of t. Hence, finally, now this is with respect to t now. Finally, that means g of x kya hai? What is g of x? Can you see here? Can you see here? This part. Okay, this part. What is g of x? G of x is integration of f of x dx is equal to integration of f of phi of t phi dash t dt. Okay, now this is the proof, right? You can check how many times this proof has been asked in the exam. Okay, this is one of the very important proof of integration. Okay, now this was the first proof for today. Let's move on to the second one. These are some of the results based on what we have done in the previous part. Now this is very important result. We are going to use this in many problems. Okay, now what it says that let me say that let I equal to integration of f of a x plus b. Now what we have done in the previous case, abhi jo humne kiya tha, this was something nothing or something but इंटीग्रेशन बाय सब्स्टिट्यूशन. दैट मीन्स अगर x के बदले हम लोग कुछ और फंक्शन भी सब्स्टिट्यूट कर रहे हैं, देन वी कैन इंटीग्रेट. Right now here let me start with, I'll explain you in problem also how we use the substitution method. Okay, now let me put ax plus b is equal to t. Now if I take the derivative with respect to t, now this is not we are not going to use this in actual problems, but ये statement नहीं आएगा. Differentiating both sides with respect to t. Okay, we get a dx by dt प्लस b का डेरिवेटिव तो 0 आएगा और t का डेरिवेटिव आएगा 1. That means a dx. Okay, if I cross multiply this dt, 1 into dt is dt. Okay, that means dx is equal to dt upon a. Let me come back to the problem. ये मेरा problem है, right? So I is equal to integration of f of ax plus b. Now what I'm going to do is, as I said here, I'm going to substitute f of ax plus b will be replaced by t. Okay, now dx, as we can see here, dx will be replaced by dt upon a. Okay, and as per the rules of integration, constant term को हम बाजू में निकालते हैं. We take the constant term outside the integration sign and we have f of t dt. Right, now my theorem already says that integration of f of x dx is equal to g of x. Okay, so when we are integrating with respect to x, it is g of x. Now when we are integrating with respect to t, that will be equal to 1 upon a g of t plus c. Now what is t? I have to bring back the original value. What is t? T का value है ax plus b plus c. Hence, what we have done is integration of f of ax plus b. Now, very important thing, although I'm not solving the problems right now, I would like to discuss this with you before I move on to the next part. Like in derivatives, if we are aware that derivatives में हम लोग क्या करते हैं, there is something called as composite function. All right, so let's say for example sin 2x है. Let's say for example sin 2x is there. तो sin 2x का डेरिवेटिव कैसे लेते हैं? sin 2x का डेरिवेटिव लेंगे हम लोग treating this as the main function. I'll take the derivative as cos 2x and I'll multiply by the derivative of 2x, that is 2. Right, so similarly here many people feel कि यहाँ पे हम लोग डिवाइड कर रहे हैं डेरिवेटिव से, because ax plus b का डेरिवेटिव क्या हो जाएगा? a हो जाएगा, उसे डिवाइड कर रहे हैं. It's true, but this rule is applicable. Very important, very important that this rule is applicable. This rule is applicable only when x is replaced by linear quantity. You can see there is a linear quantity. Unlike derivative, कुछ भी replace. So like for example, if I'm asked, if he asked me to find out derivative of sine root x, definitely I will find out the sine root x का derivative. Like for example, what I'll be doing is cos root x into derivative of root x. That we do in derivative, but it is not possible यहाँ पे. That does not, see again, let us not confuse ourselves. This is very important, listen carefully. That does not mean कि sin root x का integration नहीं निकाल सकते, but there is some other method. We cannot use this over there. So what I'm saying is this rule is applicable only when x is replaced by linear quantity. That is, यहाँ पे हमने लिखा है ax plus b. It is not applicable if x is replaced by anything other than linear quantity. Anything other than linear quantity, let's say root x है, log x है, x cube है, x square है, anything other than even cos x, cos inverse x, anything, right? So this rule is applicable only when x is replaced by a linear quantity. How does this work? Let me explain you. How does this work? Now, for example, integration of sin x, let's say sin x है, आपको मालूम है sin x का इंटीग्रेशन माइनस cos x है. तो if I take integration of sin 2x, it will be sin x का इंटीग्रेशन होता है माइनस cos x, तो this will be minus 2 cos 2x and we have to divide by the coefficient. डेरिवेटिव का वर्ड यूज नहीं कर रहा हूं, I am going to divide this by the coefficient of x, that is 2 plus c, right? Now let's move on to the next. This is again a very important proof. Result है छोटा सा, but इसका proof बहुत important है. Not proof in the sense result बहुत important है यहाँ पे, right? ये जो result आता है ना, ये बहुत ही important result है यहाँ पे. Okay, now I have the question as, let's say I have the question as integration of f dash x divided by f of x. Okay, now I'll put f of x equal to t. जो भी फंक्शन f of x है डिनोमिनेटर में, उसको मैंने t कंसीडर किया है. राइट, नाउ लेट्स से अगर मुझे इसका डेरिवेटिव लेना है, तो f of x का डेरिवेटिव क्या है, f dash x. Okay, now I am not going to use the dx by dt because directly 1 dt मैं लिख दूंगा यहाँ पे. That means ये अभी I is equal to, coming back to the question, f dash x multiplied by dx will be replaced by dt, right? And f of x will be replaced by t. तो यहाँ पे फिर से देख लो, इसके बदले हमने क्या कर दिया, dt लिख दिया, और 1 अपॉन एफ ऑफ एक्स के बदले 1 अपॉन टी लिख दिया. व्हाट इज द इंटीग्रेशन ऑफ 1 अपॉन एक्स? 1 अपॉन एक्स का इंटीग्रेशन लॉग एक्स है, तो यहाँ पे आएगा लॉग ऑफ टी प्लस सी. दैट मीन्स इंटीग्रेशन ऑफ एफ डैश एक्स अपॉन एफ ऑफ एक्स डी एक्स इज इक्वल टू log of t. क्या है? t is f of x plus c, right? This is the second one. All right, let's move on to the next one. Let's move on to the next one, that is the third one. Now इसका प्रूफ हम करते हैं पहले. Once again, my problem is I is integration of f of x raised to n into f dash of x dx. Naturally, just like the previous case, I'm going to do one thing. I'm going to put f of x is equal to t. इसका डेरिवेटिव आएगा f dash of x into dx is equal to dt. Once again, I'm not going to use the word differentiating both sides with respect to t वगैरह, ये सब नहीं करना अभी बार बार. That was only for the first part. Now I is equal to, look at this, f of x इधर है ना, f of x, इसके बदले में लिखूंगा t, ऊपर उसके कौन है, n है, एंड f dash of x dx के बदले क्या आ जाएगा, dt आ जाएगा, राइट? अकॉर्डिंग टू द स्टैंडर्ड फॉर्म जो हमने कल किया था, x रेज टू n का इंटीग्रेशन है x रेज टू n प्लस 1 डिवाइडेड बाय n प्लस 1, तो यहाँ पे आएगा t रेज टू n प्लस 1 डिवाइडेड बाय n प्लस 1 प्लस c. Hence यहाँ पे what we have done is integration of f of x raised to n into f dash of x dx will always be equal to, t के लिए क्या आएगा इधर वापस, f of x raised to n plus 1 divided by n plus 1 plus c. All right, now this is the third one, today's third proof. Okay, now let's move on to the next one, that is the last one for today. Okay, now this is, let us say that integration of f dash x upon root of fx dx. ये मेरा problem है. Let us take it as a problem. As usual, just like previous two questions, I'll put f of x is equal to t. That means f dash of x dx will be equal to dt. I'll come back to the problem. The problem says that integration of f dash x into dx is dt, and यहाँ पे divide by root of f of x के बदले क्या आएगा, t आएगा. So this is 1 upon root t dt. Now if you remember yesterday we did this 1 upon root x का integration है 2 root x. So यहाँ पे integration आएगा 2 root t plus c. Now root t का वैल्यू क्या है, f of x है. Hence यहाँ पे जो इंटीग्रेशन ऑफ f dash x अपॉन is equal to 2 root f of x plus c. All right. So this is the last one, but remember, I would like to discuss few important things about what we have done today. Is what we have done is this first proof. इसका प्रूफ है ना, आपको समझे ना समझे इसको रट्टा मार लो, इसको बार बार पूछा गया है राइट एग्जाम में. सो यू हैव टू डू दिस प्रूफ. सेकेंड पार्ट जो है इसको हमने प्रॉब्लम्स में बहुत यूज किया, बट वेरी इंपॉर्टेंट थिंग जब हम करते हैं इंटीग्रेशन ऑफ एफ ऑफ एक्स इज जी ऑफ एक्स प्लस सी, देन इंटीग्रेशन ऑफ एफ ऑफ ए एक्स प्लस बी इज इक्वल टू 1 अपॉन a g of ax plus b होता है. Now important thing here is this result is applicable only when x is replaced by a linear quantity, that is ax. ओके आप पूछोगे सर यहाँ पे तो आपने सिर्फ 2x लिखा है, यहाँ पे प्लस बी नहीं है, प्लस बी वाला पार्ट नहीं है. दैट प्लस बी कैन बी प्लस 0. डू नॉट वरी अबाउट दैट. बट वेरी इंपॉर्टेंट थिंग, x कोइफिशिएंट उसका होना एक जरूर, कोइफिशिएंट भी है उसके साथ, तो वो कोइफिशिएंट से डिवाइड करना है. सो द रूल इज अप्लीकेबल व्हेन द x is replaced by a linear quantity and it is not applicable for any other thing other than the linear quantity. Hence I have written here नीचे important note लिखा है. Now यहाँ पे भी बहुत ही interesting part, ये भी बहुत बार use करते हैं हम लोग, right? Now for example यहाँ पे हम लोग कुछ एक हाथ क्वेश्चन मान लो ले लेते हैं. Let's say for example यहाँ पे अगर मैं लेता हूँ, यहाँ पे क्या होना जरूरी है, द न्यूमरेटर मस्ट बी द एग्जैक्ट डेरिवेटिव ऑफ द डिनोमिनेटर. लेट्स से फॉर एग्जांपल i इज इक्वल टू इंटीग्रेशन ऑफ लेट्स से x प्लस 3 है डिवाइडेड बाय x स्क्वायर plus 2x plus 5. There is a type of problem. So I'm not going to solve the complete problem, but I'm trying to explain you. यहाँ पे क्या कर सकते हैं, यहाँ पे अगर exact derivative है, let's say for example यहाँ पे अगर एग्जैक्ट डेरिवेटिव मेरे पास है, तो यहाँ पे मैं x, दिस इज यू कैन सी एफ डैश एक्स अपॉन एफ एक्स है, राइट. दैट इज वन वे, और यू कैन पुट एक्स स्क्वायर प्लस 2x प्लस 5 इज इक्वल टू टी. In case sometimes there is no exact derivative, then just try to adjust the derivative in the numerator first and then try to solve the problem. So there is a special type on this. Whenever in one of the class I'll be discussing the types of problems there. We are going to discuss this kind of problem. Now another important thing, ये जो 3-4 ये जो है ना, ये होता है, बट बच्चे इसको भूल जाते हैं और unnecessarily they try to use the substitution method, which is waste of time. As I said here also, if you use substitution method you get the answer, but क्यों करना है, because this is clearly f dash x upon fx, right? तो उसको substitution में time waste मत करो. Similarly यहाँ तो बच्चे फिर भी कर लेते हैं, बच्चे यहाँ पे भूल जाते हैं करना this kind of problems. All right, and this kind of problems. All right, so that's it for today. See you in the next class. Wait a minute. So I'll see you in the next class, where I'll be discussing the next set of standard forms, that is tan x का, cot x का, sec x and cosec x का integration कैसे निकालते हैं, and their standard forms. उसका proof भी मैं बताने वाला हूँ आपको. So till then, bye bye, see you. इसको जब भी आप कर रहे हो, remember most important thing, don't just watch this lecture. Take a notebook, take a pen, एक जगह बैठ के इसको सॉल्व करते रहो, राइट? डोंट जस्ट वॉच द लेक्चर, उससे कुछ फायदा नहीं होगा। बाय बाय।